Okay, some of you didn't get a chance to finish up the board battle dimensional analysis problem, so I'm going to kind of step you through it. I think everybody got done with the first problem, so I'll start on the second problem. The second problem started with a given of 2.33 warp factors, and we were trying to convert that to knots, how many knots it was. So I'm going to have a lot of conversion spots here that we'll put stuff in. Okay, and the first thing it said was that 1.71 warp factors was equal to 5 times the speed of light. Well, the speed of light was 3.00 E8 meters per second. And so what you could do is you could go ahead and take that times 5 real quick. And you need to keep your 3 sig figs. And so many of you did that, and you get 1.50 E9 meters per second. So this is the part that people were confused on. I can put at 1.50 E9 meters per second. That's already a fraction. It's a unit that's in a fraction. So the meters I can, put up here in the top, but the per is this line right here. So the second unit actually needs to go down here on the bottom somewhere. So I'll take it times second. Okay. So the second can go down here. Now the warp factors cancel out. Okay. Let's go ahead and cancel them out in red. Okay. So now I have a unit with meter on the top and a second on the bottom. I know that really bothered people, I noticed on Friday, but that's the way you can do it. Meters is on the numerator and seconds is the denominator, so we can go ahead and write it that way, and we can put several units down here. So it's always dimensional analysis. We're really looking at the units and analyzing them. Okay, I want to actually get instead of meters in the top, I want to get to yards, and instead of seconds on the bottom, I wanted to get to hours. And the reason we wanted to do that, I think most people understood why we wanted to do that, because there was a conversion factor that was given that said that 2,000 yards per hour equals 1 knot, and we're trying to get to knots. So that way, if I can get my meters to yards and my seconds to hours, then I'll be able to do a nice little conversion there at the end. Okay, so let's go for meters first. So I can do 1 meter on the bottom is 100 centimeters on the top. I want to do that because I want my meters to cancel. And then I could do 2.54 centimeters. Remember, this is the bridge that I want you to memorize. Equals 1 inch. And that would cross off my centimeters. Now I'm in inches. And then I could do 36 inches is 1 yard. And therefore my inches will cancel out. And I'm in yards. I'm not going to circle that because that's not exactly what I want. I want knots. But I am going to stop there because I wanted yards on the top, so that's good. So let's go back and do our seconds, which I have on the bottom. And I could put 3,600 seconds on the top and 1 hour on the bottom, and my seconds would cancel. So now I have yards over hours. So what do I do to get into knots? Well, I have one more conversion factor right here that I can put in. So on the top, I'm going to put 1 knot. And at the bottom, I'm going to put 2,000 yards. Okay, now we have another one of those fraction things. Yards per hour. Where's my per line? Well, my per line is here. So where am I putting the denominator of this thing right here? Well, I'm going to put it on the top. Times hour on the top. And this should make sense because what are we doing? We're dividing right here. It's 2,000 yards per hour, putting in the bottom right here. So I'm dividing by, technically, a fraction. What do you do when you divide by a fraction? You flip it. Hours over 2,000 yards, and you multiply, right? You multiply by the reciprocal. So I should have hour on the top, which I do, and 2,000 yards on the bottom, which I do. Now that's good because yards were on the bottom and on the top, and hours were on the top and on the bottom. And so, aha, I found you, knots. So if you do all the math on this, I should have 3 sig figs because of the given. I had 3 sig figs here too, and also in this, and all these other things are just definitions. So my answer ended up being 4.02, 3 sig figs, E9 knots. Okay, that was the warp factor problem. All right. The third problem was pretty tough, and I don't think anybody got through with that. We were given basically a density of a polluted lake. It said that it's 0.4 micrograms Hg. Now this was confusing. Micrograms of Hg. That is not a unit. That is actually a chemical symbol. That's the symbol for mercury. So people thought it was hectograms or something, and that's messed up. So 0.4 micrograms of mercury in a milliliter, or I could write as a centimeter cubed of water. So that's a density, right? It's a mass over a volume. 0.4 micrograms of mercury in every milliliter or centimeter cubed of water. What I'm trying to find out is the amount of kilograms of mercury in the lake. That's a mass. And so here's a density, up here's a density, and I'm trying to find a mass. So they must give me something to figure out the volume, and they do. They tell me an area is 100.0 square miles, and the depth is 20.0 feet. And that's not a volume, but I could make it into a volume. If I take the area times the depth, that'd be 3 dimensions, and I could have a volume. And we know density equals mass over volume, and we're trying to solve for the mass. So the mass would equal the density times the volume. Now, so that means if I want to find the mass, I would take the density, which is 0.4 micrograms over cubic centimeter, times a volume. But what units do I want that volume to be in? Well, I'd want it to be in centimeters cubed. How come? Because I want to cancel out with this one down here and have a mass, which is only in micrograms, but I could convert that to kilograms. So if I take this density right here times a volume, I want the volume to be in cubic centimeters. Well, that's going to be a problem. So I need to do a lot of work on that. So, and I have to do some work even before, because these two, I can't multiply the area and this depth together because they're not even in the same units. So let's take this area in miles squared. So it's 100 square miles. And let's go ahead and convert that into square feet so that I can multiply it by the 20. So if you remember how to do this, this is a little tricky. I have 1 square mile equals how many square feet? Well, how many feet are in a mile? There are 5,280 feet in a mile, but these are square feet and square miles. So what do I have to do this number? I have to square it. Okay, so miles squared then would cancel out. So I'm going to take 100 times 5,280 squared times 5,280 squared, and that's going to be a really big number. That's going to be, and I would have to have 4 sig figs because the 100.0 still has 4 sig figs in it. So I would have 2.788 E9 square feet. Okay, now what I want to do is I want to take that times my 20 feet depth to get cubic feet. And that 20.0 is 3 sig figs. So when I do that, I'm going to get 5.58. I just need 3 sig figs. E10 square feet. So cubic feet. Sorry, I just took it times my third dimension. So now I have cubic feet. Okay, so that's a volume. Now, what volume do I want it to be in? I want to put the volume up here in this spot, right up here. So I need to have this in centimeters cubed if I want to take it times this density. Okay? This is a tricky problem. It'd been interesting to see if any of you could have figured this out in your groups. Okay, so I'm going to convert this to cubic centimeters. So 1 cubic foot would be 12 cubed inches cubed, right? If I convert this to inches cubed, my feet cubed to cancel out, I got to cube that number, 12. 1 cubic inch would be how many cubic centimeters? Well, it'd be 2.54 cubed centimeters cubed. So inches cubed to cancel out. And I'm going to get a, if I do the math on there, I'll have my volume in centimeters cubed, and that ends up being like a 1.58, keeping my 3 sig figs, E15 centimeters cubed. Okay, so there's my volume. Finally found my volume of the lake in centimeters cubed, and I could take that times the density of the polluted lake, 0.4 micrograms of mercury in every single cubic centimeter. And when I multiply the density times the volume, I should get a mass, and you'll see my units actually cancel out, and I have a mass unit of micrograms. Now, what I want, though, is in kilograms, so I actually can just attach on another dimensional analysis problem right here onto my math problem. And I know that there are, if you remember from the other day, that there are 1 billion, 1E9 micrograms in 1 kilogram. And my micrograms would cancel out, and kilograms is the unit of mass I would have. So I'll take 0.4, which, by the way, only has 1 sig fig, only one, times this volume, divided by 1 billion, and I get 6. If I do it out, I'll get like 632,000, whatever. But I only can have 1 sig fig, so it's going to be 600,000 kilograms, or 6E5 kilograms. And that's how you would solve that problem. So it's a little formula problem, but it's also clearly a lot of converting things into the right unit so that you can use that formula. So that's a really tricky dimensional analysis problem. Hopefully you understood it, or you can pause it and go back and try to do it yourself and see if you come up with the right answer.